This is my number line. When the number gets bigger, in which direction am I moving? To the right. Would you go ahead and say that 87 is greater than 8.7? You know why? Because I moved the decimal point to the right. When the decimal point moves to the right, your number gets bigger. What does that tell me? Come on, use your brilliant logical minds. If the number gets bigger when the decimal point moves to the right, what can I go ahead and immediately know?
It gets smaller when it goes to the left.
It gets smaller when it moves to the left. And you know why that is? Because this number on the number line is less than this number on the number line. Because it's to the left of it. Isn't logic cool?
Sometimes.
Sometimes. Other times it's difficult. And still others it's trouble.
That's why I've created my own logic.
Yeah, I know. And it would be cool if the world lived according to your logic. Or it'd be wonderful from Lauren's perspective if it lived according to Lauren's. Or from Kevin's. But the key is, we've got this thing that's called the world as the world. And we have to understand logic from that perspective.
See, my logic interacts with real logic in some ways.
In some ways. And you know what that means? As opposed to in all ways, that means the difference between a greater than 87 and a 100. Right? Because those 13 times it doesn't. Let's look at the second side of the chart. On the second side of the chart, what we have is we have negative exponents. 8.7 times 10 to the 1, but now we're going to make that 10 to the 1 10 to the negative 1. Well, we knew how 10 to the 1 looked. 10 to the 1 looked just as 10. How is 10 to the negative 1 going to look? It's going to look like this. The way we make a number that has a negative exponent positive, ta-da, surprise, 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 we reciprocate. After all, what is this? This is 10 over 1 with a negative exponent. What's the reciprocal? Positive 1/10. If you will, Lauren, how do I turn 10 to the negative third into a positive value?
Oh, that's what you did up there?
Yeah, that's what I did over here, right? I took, here I have 10 to the negative 1, and that became 1/10. A negative value, at least a negative exponent, became a positive exponent by reciprocating.
So you just do...
Did you figure that one out?
3 over 10?
Is that the correct answer?
You'd go 3 over 10. I'll give you a hint. Let's begin with this. What's the reciprocal of 10 over 1?
1 over 10.
See this negative 3? It now becomes a positive 3.
Why'd you put it there even?
Because I want to turn it from a negative exponent to a positive exponent. And the only way I can do that is by reciprocating a fraction.
Yeah, but what does the 3 do there? Like, is it times?
Yeah. This is 1
It's the power.
times 10 times 10 times 10, which is, how many zeros do I have?
Oh, it's 3.
So,
1/1000. In other words, 10 to the negative third equals positive 1/1000. Let's look at our next example. 8.7. In fact, we kind of did that one. Let's go to the last one. Can you go ahead and read it to me, Ron? The last one on the left-hand side in the box, the third one. 8.7 times...
What page?
Page on the left-hand side. Page 130.
Yeah. So C is so problem C, it's 3 point,
No, one up top, right up here.
yeah, oh, up top.
Yeah, third one.
Okay, so 8.7 times 10 to the negative third power.
Well, did not the one we just did, right?
Yeah.
Let's do this. Let's do it times 10 to the negative fifth.
Okay.
Okay? Rewrite the problem for me. What's another way of rewriting this with a positive exponent? And just tell us what it is. How do you rewrite this problem?
It's 8.7 times 1/10 to the fifth power.
Good. And we can do this in one of two ways. I'm going to go ahead and do it this way. And the reason I do it here, because 5 to the 1 is just going to give me 1 times 1 times 1 times 1 times 1, which is just going to give me 1.
Times 1.
Huh?
No.
Yeah, well, and then 10 to the fifth power is going to go ahead and be 10 with 5 zeros, meaning it's going to be 1/100,000. So this will be equal to 8.7 times 100. Look! 1, 2, 3, 4, 5. 5 zeros. So 8.7 over there, so on and so forth. Let's look at a couple of these. Couple of examples.
Wait, what's our homework?
Good question.
Yes and no.
Your homework is going to go ahead and be this, if you will, because we have a long break. 2.9.
We don't have a long break yet because we still have Thursday.
Ah, that's right. Let's do 2.9. Numbers. Sorry, guys, you know I'm tougher than Mrs. Ann. Let's do numbers 10 through 31.
I knew it was going to be 30 something, 10 to 30 something.
Yeah, why do you want to do the other ones? Because you already have the other ones set up here. And basically what these are is simply, you know,
On page what?
128. And then the exercises on, this is going to be on page 128, numbers 10 through 31. Forget about the evaluations at the bottom, because essentially what you can just hear is you can just multiply these things out with a calculator.
Wait, 128 or 138?
128. And this is going to be numbers 10 through 31. And then,
That was the first thing, right? That was the first thing.
that was the first thing, correct. That was lesson 2.9. And then what we'll do is for lesson 2.10, do numbers
What page is that?
130.
132. For 132, do problem numbers 1 through 8. And those will cover the ones that we did. What we'll do on Thursday, I'll point this out to Mrs. Ann, is we'll do these over here as the opening exercises, and then perhaps we can spend the entire class session on doing the review lesson. That's going to be these things over here. And it won't be that difficult because we can just pluck one problem from each section of chapter 2, because you will have the practice test as a take-home exam for this unit. Okay? I don't know. Obviously it's going to be like you'll do it over the course of the break, and we're going to be gone for about 3.5 weeks, so.
And you're gonna have all your homework done
Yes.
for that class, all of you.
I'll try, but even if we don't, we should get popcorn, right?
Stay on them.
Right?
Well done. Give yourself a big round of applause.
Okay.
Great job.
So that is the homework.
Thank you.
Well, the homework's going to be the
Yep.
2 lessons. But again, we'll go into more detail on the scientific notation on